Dear member of the Luxembourg industry ecosystems, dear neighbors from the greater region and from the rest of Europe, dear solution providers, welcome to this new episode of the L-DIH Talks addressing the digital transformation in an Industry 4.0 context. My name is Arno Lambert. I'm the director of the Luxembourg Digital Innovation Hub. I will be your host today. For the ones not yet familiar with what L-DIH is, let me first quickly introduce what it is so that you can actually realize what we are doing. Well, who we are the one-stop shop digital support for the industry. So our purpose is to connect the industry and their digital needs with, be it the providers that have solution, be it the academic world, be it the institution for different aspects, incubators, all the ecosystems. We are actually working at the national level as well as European level, being part of a European Digital Innovation Hub network that is currently being built. We are also a partnership between the Federation of des Industries Luxembourg, the Chamber of Commerce, the Lux Innovation, University of Luxembourg, and the Fonds National de la Recherche. So this basically tells you in a nutshell who we are. But before we're starting and introduce also the speakers that are with me, let me first go into a quick introduction of the platform. You're here registered together with us, and you will see on the right-hand side, you have a chat and question, polls, and people. People will show you the list of people connected, and people are still joining, thank you. But if you have questions for the audience during the presentation, and we'll take those questions at the end of the presentation, please use the questions, the question section. If you have anything that you would be chatting with anybody, then you would use the chat button, but questions to the audience would be on the questions. You will also have certain polls being requested for your advice, and that will be in the poll section. For your information, the session is actually recorded so that it can also be watched again in the second stage, and also for the one that have registered but that would have missed. In today's session, we will be focusing on the production, digitizing the production tools in an Industry 4.0 context. And for that, let me quickly bring you a certain amount of context. Industry 4.0, I will not go into the first, the second, third, and fourth industry revolution, but Industry 4.0, it's about the combination of the physical and the digital and the cyber, meaning the connectivity. So Industry 4.0 is really about digital, connected, and smart. And that's only the premise of a future digital ecosystem where the value creation will not only be done online and from an agile point of view within the industry or within one typical production, but connected to the entire value chain. But what I have for the scope of what we're discussing, a digitalization landscape is much more than the production tool. It starts with a customer, the management of the customer up to the supplier, including support functions. That's a true landscape of digitalization. However, in this session today, since we already covered the customer side, the supplier side, we're going to focus on really the production side, which is typically the place where anybody would start a digitization program into manufacturing industry. And for this, I have the pleasure to welcome two guests. Originally, as you have seen in the invitation, Fabrice Hansen from Vice President Digital Transformation Process Automation from Polverse was supposed to join. Unfortunately, he could not join us, but we have a great replacement with Sébastien Wirtz, who is the General Manager of Powell's Incube. So we're going to welcome Sébastien. We'll hear from you shortly. And also we have with us Pascal Dein, who is the Director General of Cpi. And both of them are going to actually share their experience and their customer experience of the whole topic of transformation, the production tool, digitizing the production tool, what makes sense and why it makes sense. Before we go to the topics themselves, may I ask you to go and select on the poll section of your screen. The key question I have for you today, dear audience, is to understand your production tool or your production line. How old is it? Is it less than 5 years old? That would be A. Is it between 5 and 10 years old? That would be B. Or is it more than 10 years old? The idea here is to judge the type of ecosystem that you're using for your production lines so that we can also nurture basically the discussion. So if you could take the moment to actually submit your vote, and we will be looking at that in a second. And while we are answering to the question, I would like to come back to a study that has been produced by the European Investment Bank study in 2019 from memory about digital adoption in manufacturing. And we will focusing on the left side of the graph, the rest are for other industry, but that's really manufacturing. You have small and large. Small is less than 50 employees and large is more than 50 employees. And I must say, in Luxembourg, we should recognize that the majority of the manufacturing industry would fall under the small categorization here, but of course we have also representation of the large. And here what we can see definitely is that Luxembourg from the small point of view is ahead of the EU means, but well below the US one, and the large is a bit slightly below on the other side. But we see also a big gap between what we call the large manufacturing industries and the small manufacturing industries. So I'm sure there is really clearly an element of discussion that will come into the topic. And now we know also that most of the respondents that are attending today have a production line that is less than 10 years old, meaning, sorry, more than 10 years old, sorry, I read it wrongly, more than 10 years old, which is something to take into consideration in the discussion of today. But without further ado, I want to leave the floor to Sébastien as a first person that's going to share its experience, and we're moving basically from knowledge there definitely to experience. So Sébastien, the floor is yours. Thank you for joining us and for sharing your experience about the digitization of production line and production tools.
Thank you, Arnaud. I believe everybody can see now my presentation.
Yeah, all good.
Yeah. Exactly. So I'm Sébastien Wirtz. I'm replacing today Fabrice Hansen, which is in a business trip. And inside Paul Wirtz, we are always the motto of business first. So he's excusing himself, and he asked me to replace him on the pied levé to make this presentation, which is not a big deal for me since I'm following this topic deeply with the collaboration of the digitization team inside Paul Wirtz. To present myself quickly, I'm working since 20 years inside Paul Wirtz. I'm a mechanical engineer, and since now 6 years, I'm the head managing director of Paul Wirtz Incube, which is in fact an incubator for startup. To present Paul Wirtz to the one who may not know yet Paul Wirtz is a 150 years old company based in Luxembourg, specialized in the definition of blast furnace plant. So we are building plant in the iron and steel making around the world. So we have 22 entities around the world. And what we do, it's from the concept to the realization, the engineering, the project management. We supply a complete plant from A to Z. What we have seen in the last 10 years is that we have switched a lot of our turnover into the servicing, and I will come to that afterwards. And of course, we had to follow a little bit the trends, which is Industry 4.0 that you can see in the middle of this slide. The trends, not the hype, because we have some hype. Some people are selling Industry 4.0 as a hype. We did investigate that deeply to resolve issue we face on our customers. We don't operate ourselves the blast furnace we are building. We have customers who do that. We help them to understand the processes and optimize their production. So to give you a little bit of the roadmap of the digital history inside Paul Wirtz, it starts always with automation level 2. We have built the BF Expert. As you can see, we started the journey in 2008, where we started to analyze all the different data we had around the blast furnace in order to optimize the production on our customer site. So we have defined in 2013 the TPDS. It was a digital camera that we installed on the different tuyères we have around the blast furnace to analyze also the shape of the flame and detect issue before it just generate big issue inside the blast furnace. In 2014, SMS, the new mother company of Polwart, replaced ArcelorMittal, which was the shareholder at that time. So we defined SMS Digital with the Polwart, with the team, and the journey, the real digital journey, started in 2016, where we really define a digital roadmap. It was really the time at that stage to say, okay, now digital is really the way to go. So in 2016, we defined a strategy which can be think first as a design thinking. That was the idea in the beginning. Fabrice and I must say, we were not keen about this design thinking, because design thinking is going to the customer and analyze with them what was wrong. It's lead, in fact, to continuous improvement and not disruptive innovation. So we changed completely. So it was a big fail to go for design thinking. So what we analyzed there at that time, we said, okay, let's see what are the trends in Industry 4.0, and you see a schema there, which was defined by Boston Consulting Group at that time. And for each of the pillars of Industry 4.0, we define internally where could be the trends that can be effectively applied by our customer, for our customer, by Polwart, and help them. So you could have, for instance, the PV cloud, because cloud, if you remember, like 6 years ago, people were not keen, especially our customer, were not keen to have data on the cloud. So we secure a private cloud inside Polwart to have a trust between us and the customer. We define some smart equipment. I will come back to that. Smart maintenance. So we identify for all the pillars certain key product that we had to define for this digital roadmap. Of course, at the same time, we develop the incubator of Polwart, because what is important to know is that all the technologies exist on the shelf somewhere in the world. Startups or suppliers have defined some technologies. It was really important to go out of the building, scout the technologies, and apply them quickly with us in collaboration way, in order to reduce the time to market of all these digital products. People tend to invent inside the house the different digital tools. This is not the way to go. We said we're going to collaborate with existing technologies in order not to define them ourselves. So the main driver in 2016 were to define, in fact, pillars, and that's the 3 main pillars that we have there. We wanted to increase the servicing. Servicing, if you take the example of General Electric, General Electric now today is making most of this turnover using servicing. That was the same trends we faced inside Polwart. We doubled in the last 3 years the turnover for the servicing, and the customer wanted to go from CapEx, capital expenditure, to OpEx, operational expenditure. So we said, okay, what about defining our product and not selling the product, but renting the product or leasing our product and being paid on performance as a service? And that's a trend that we are selling today. We are asking our customer to pay us according to the performance we are applying. And that's a change, completely change in the business model we face. And I can come back to that if you have questions in the end. The second one is the artificial intelligence. A big hype also, everybody speak about artificial intelligence, but it has to know that inside Polwart, we have acquired like 15 years ago Sachem, and Sachem was in fact a rule-based engine that we have maintained and we have now updated. Rule-based engine, you have to see it like capturing the knowledge of the people. The process engineers and maintenance engineers are key in our industries. So we wanted to capture the knowledge in a rule-based system. And then on that, we apply some machine learning, and I will come back to this in the next slide. Machine learning is in fact just a layer over it that just analyzes the data and make forecasts of predictive maintenance to resolve specific issue that you identify inside the blast furnace or the plant that you want to monitor. And of course, connected product, you have to define some sensors, some specific sensors, missing sensors that were not there, to have some data that can be applied, of course, afterwards in this artificial intelligence environment. So the different step we made to the digitalization. The first one is, of course, to acquire the data. It seems trivial, but in fact, a lot of people tend to forget that the data are not there, and if they are somewhere, not organized. So it's really important to start with the first step is to analyze the data which are missing, acquire them, so make a quick data acquisition of this data, organize them and store them, and that's why we define the PV cloud with the customers. The second one is to run the rule expert to have a data validation of this data, the data processing. It's in fact to see if the data you are receiving are in a good range, if the sensors are working correctly, giving good data. This is something also that people tend to forget, but it's really important to have data which are really, let's say, maintained, or the sensors must be maintained to give the right data, and you have to analyze if the data are okay before to process them in any machine learning system. So KPI tracking, of course, it's nice to acquire some data and to process them, but you have to start with the end in your head, meaning what are the KPI, what kind of quality you want to have in the steel, what kind of temperature you want to analyze. It's really important to discuss with the customer what are the KPI for them in order to define the performance he wants. Dashboard and reporting, that's the cherry on the cake when you have done all this different step. And we use BI expert, define inside Polver to do so. And then when everything is clean, I must say, you are using AI expert, which is in fact a machine learning system that we have defined inside Polver, and you start to identify the pattern recognition. You can start with smart predictive maintenance or smart maintenance, as you can call it. And this is only done at a certain level when all the data are clean and processed correctly, and you have identified all the API you want to have. Advanced modeling, it's another layer, because some of our customers have their own data scientists. So they can define their own injection AM or artificial machine learning system. And afterwards, you have a digital shadow, meaning if you do a digital twin and you apply all the data on the factory, you can come with a smart factory definition when you have done all these different steps. We are defining tools for engineers by engineers. It's not a way just to take some geek and define some machine learning and artificial intelligence. We are engineers, and our customers have engineers on site. So it's really important to capture the knowledge of our different engineers and exchange with the knowledge of our engineers on the customer side. So you have to access the raw signal, define, as you can see in this schematic there, the different rules that the data will follow up according to the expertise of the customer. And then you can have some deviation alarm at set points and a recommendation to operate the blast furnace. To do so, we have defined a rule expert that you can see here, an example that we capture directly, and we call it the white box. It's really the data entering this kind of schema, and then you have really the trends to be followed. On the right side, small one, but you have all the dashboard with the connected equipment, where in fact directly afterwards you can see deviation alarms according to the equipment which are monitored using this different data. When you define such a step, it's really important to go for the process engineers first. What we want is predictive model and pattern recognition to be analyzed by the process engineers. So we are providing AI experts to the process engineers of our customers. So we define them a toolbox. They can play around. And if they have data scientists, they can inject directly different model into our existing system. So it's not a closed system, it's an open system that the customer can play around with it and inject their own data and own machine learning model inside it. We have to start with the finality, and we don't do machine learning for the sake of it. In fact, applying machine learning on such a production system like a blast furnace, if you imagine a customer which is producing 2 million tons a year of hot metal, and by using machine learning, and that's effectively what we do today, you can reduce the cost by 5 kilo by ton of hot metal produced. You can go to an economy of 2 million per year. So it's really important to analyze what kind of issue or what kind of KPI you define in the beginning, and then you start to analyze the machine learning and how the machine learning can be applied to achieve that goal. The lessons learned, the first one is the feature engineering. When you start a project like machine learning, it's really important to have in the same room the data scientists, which are defining the machine learning processes, the process engineers, and we did it inside Polwet by having our startups and the process engineers in the same room, defining together the different features, and the maintenance. The maintenance, in fact, I see that in different companies. Maintenance, the data of the maintenance are most of the time in SAP, lost in SAP, but this data is really important, and the expertise of the maintenance guys are really important to see the effect of what you are producing on the production line. So it's not an easy step, I must say, because data scientists, they know the technologies, they know how to program machine learning. The process engineers, they know how the process works. To make them work together, I must say you must be an alchemist. You must translate the language from one process engineer to the data scientist, because the data scientist doesn't know how a blast furnace works. And the process engineers, in fact, do not know what machine learning is, and they don't have to. They have just to have a proof that it's bringing something on the table concerning the process. So you have to select the right use case. We selected the temperature of the hot metal because we said if we can not measure but maintain this temperature at a certain level, we could reduce the number of CO2 produced by the blast furnace, and CO2 produced by blast furnace is huge. So we have really to analyze that and see what kind of variable in the blast furnace can play a role, a big role or a small role on this temperature. And you have to make a combination of black box and white box approach. Most of the people believe that machine learning is just a black box. You apply a magic tool, you have the data, you inject the data, and you have all by magic something. This is not the reality. The reality is to define a white box with the rules, what kind of machine is giving us the data, what are the different processes inside, and you have to really to convert this tacit knowledge that every process engineer has in their head into explicit knowledge, and that's what we do with Rule Expert. AI Expert is the black box where, in fact, you have input and output. Of course, you don't have to know what's in the black box, but the process engineers must have a view on the output and see and make a validation of this output. Every project in machine learning starts with data quality, and this should be maybe the first point I would highlight, because a lot of data are, let's say, spread around the companies in Excel sheet, in different database access. So we have first to start with the data and clean up the data and make a good master data management in order to have a good machine learning in the end. And that's a point that is most of the time under considered. And this is the point where, in fact, you are losing a lot of time when starting a machine learning journey. and the right partners. In fact, that's Paul Wirting Cube there is data thing, and data things are there as an example. Cpi will be a good example as well. In fact, in the Incube, we are scouting technology to resolve specific issues, and we are also helping the startups to understand the business of the different corporate, and the corporate to understand how the startup are working, because they have different scope in all of them. And to conclude, it's not magic. Most of the time, in fact, people are selling you machine learning or Industry 4.0 as a magic tool. You just have to apply next, and it will work. In fact, it requires a clear vision and strategy, which is not, as Fabrice highlighted here, in design thinking. It's really to see what you can offer to the customer. The customer, in fact, may not know the benefit of machine learning. Is busy having his operation under control. So you have to offer the customer a proof that machine learning can do something for this operation. It has to reduce the cost amount of its production, otherwise it makes no sense. It requires a lot of time and energy, believe me, at least in the beginning, to get the data, to make a cleanup of the data, to define, in fact, the different models that you have to do. And a good partnership between data scientists and experts is essential. So we have not to consider the startups or the different partners you have as a supplier, but really as a partner to define together a product that can fit the industry. And the right tools, it's a good point, because in fact, machine learning is just statistic. So in the end of the day, if you are coming with a black box, which is just, I will exaggerate a bit, just a black box, which is an Excel sheet with some beautiful statistic formula, and it does the job, then it's okay. And then you can go for more complex or more sophisticated model, but you have to start small and resolve the problem with simple tools in the beginning. Make an MVP, and that will be enough. But the potential is huge. In fact, if you identify clearly the different issue you have on the customer, on your fabrication line, then in fact the potential of machine learning can be huge, and can really offer different potential in your industry. We see it every day, and we are continue to define that. Voila. You have question. I left the contact of Fabrice, but I'm also available if you have any questions.
Thank you, Sébastien, and thank you, the audience, to already post your question. We're going to take your question at once we have had the two presentations. But I have just a quick one for Sébastien. I mean, considering as we saw that, I mean, you had all the blocks about the building blocks towards, I would say, the nirvana of digitalization, starting by data acquisition, validation, KPI dashboard. So of course you're on the right hand side of the graph, meaning more helping and also playing with a large manufacturing side. What would be the key element for the smaller ones? So clearly, this has been proven, the larger one, but if you're a smaller company, 50 people, should they go basically by the blocks, kind of, meaning increase their maturity there? Or would you have any other insight to give them?
They're first to identify the different issues, and if you just investigate the maintenance department, they are coming with some issue every week, every month, and that's something which is not done in different corporates, big, small, medium companies. So we have really to identify and to listen to the maintenance people, because they are the front line, and they will bring you back some issue you have on the different production line. That's the first step. Then the second step is to identify what will be the resolution. I had an interview with different big industry in France, really huge one, and they were not able to have the data from their different production machine, because they have different machine from 20 years old to new machines. So it's really important to identify what kind of sensors you have to place on the different machine, which is just the energy consumption sensors, because just ask some companies what kind of energy a machine is using. Nobody knows. Most of the time, nobody knows. So we have to start small by analyzing what kind of data is missing, once you have identified the issue, what kind of KPI you want, and then the data, getting the data in the database and making some simple dashboard in the first step, it's enough. So, and to answer it a little bit more, since we have CPI there, in fact, when we have defined this big bang for our industry, where in fact blast furnaces are huge, you can imagine, we said, okay, our solution, data expert and AI expert, can be certainly used for small industries. And that's why we approach CPI, and that's certainly the reason CPI is there today as well. We said, okay, our business is not in workshop in small industries. Can you have a look on that data expert and see how it can fit maybe some small company, SMEs, with workshop? And I believe it could be, but Paul Wirth has not, let's say, the structure to go in and sell that to small companies. So we are providing, using the Incube as well, we are providing, let's say, expertise and help to different companies in Luxembourg. We are always keen. We are working with the FEDIL, so always keen to help and answer this kind of question. The people wants to start the journey there.
Thank you, Sébastien. Thank you for the clarity. I think it's a nice transition to CPI and to welcome Pascal on stage for learning his also experience of the digital transformation to the production tool. So Pascal, the floor is yours.
Okay, good morning, everybody. I will first try to share the presentation. So you can see the presentation, it's okay?
Yeah.
Yeah, okay. Okay. So thank you, Arnaud, and also thank you, Sébastien, for the introduction towards CPI. So CPI company, we like to name this company the ManufTech, because our mission, our vision, I would say, is to try to introduce all the digital tools in the manufacturing. So to put the digital things on the shop floor. So this is why we named this company the ManufTech. I will just come back to the quick overview of who is CPI, who we are. So I created this company here in Luxembourg in 2004. We created some operations beginning of 2013 in France to work for the defense industry, and we created also some operations in Mexico, just to follow some big customers that we have. So we are a service company, 100% service company. We're working for the automotive industry, aeronautics, energy, rails, defense, naval. And the common point of all this is manufacturing. So we are really working for people who are doing manufacturing, who are manufacturers. So we are working for a lot of customers, as you can see on the screen, 50 active clients in 12 countries. So we are working here in Luxembourg, but also, I would say, all over the world, where our customers have their operations. We are 50 people. We have a big growth. It's 30% growth per year, of course, except last year. I would like to forget, if possible, this last year, but this year we are back again to 30% growth, which is very important. And we are offering, I would say, three services. We have three business lines. The first one is industrialization. We are helping our customers to program their CNC machines. The second business line is trainings. So we are training our customers around the CAD/CAM softwares and also around machining, I would say, technologies. And the third one, and this is the one which is interesting us today, is the Cpi Digital Services. So there we have thought a lot with our customers over the past 2 years. What are their problems and how can digital tools could help them to save their problematics. So all the presentation that you will see afterwards is a presentation, made by CPI, but it's the result of a lot of discussions with our customers who are all manufacturers. So digitizing my production, what makes sense? This is the subject of the today presentation. What makes sense? Before answering to this question, I would like to insist on the fact that you need to understand why do I need to digitize my production? Why is it, I would say, mandatory? It's not, you are not going to digitize it just because others are doing it, but you need to understand really why. And if you manufacture today, you have a lot of demands from customization. You need to have the diversity of products. All the products are more and more complex. You need to configure it. The mass production, I would say, is nearly finished. You need to adapt your production to what the customer needs or wants. And also, on top of this, you have also a global competition. It means that you manufacture here in Luxembourg, but also you need to take into consideration that someone may product, another company may produce the same products, but in another company. So it's always the global competition. All these trends would lead to you need to be on top of the planning for the manufacturing. You need to you have a lot of challenges for the scheduling. You need to take care of all the products quality, and all this would lead, I would say, to higher production costs. To summarize this, you need to be more and more agile in the production, and you need to be more and more flexible. So you will face to new challenges. You need to be sustainable with economy and environment. What that mean? That means you need to control the quality of your products. You need also to be compliant with the regulations. You see on the right side of the slide, breaking silos. This is very, very, very important because, for instance, if you get an order, the people who are in connection with the customer, they will get the order, then the order will be transferred to the different departments of the company. Most of the time, you have silos. It means that it's very difficult to transfer data from one sector, one department to another department. So this is really the most challenging thing, is to break silos and to work with, as we name them, collaborative platform. It's very, very, very important. And on this platform, you can also integrate your ecosystem. So this means your customers, they can have an access to the platform, but also all the supply chain, all the subcontractors. Another challenge will be also to capitalize the know-how. A lot of people are leaving your company because they are going they retire. So you need to transfer this knowledge to the younger employees. On digitizing all your process will also help you a lot by doing this, in order to educate the workforce of the future, as we say. So for us, following the large number of discussions we had with our customers, we resume, I would say, we made a summary of the key factors to success in 2021. You will need to adopt digital tools in order to have an holistic and systematic approach of the business. What do we mean by saying this? Is that when you try to digitize your production, because here we speak about production, you don't forget also the rest of the company, and you have to have the company, the whole. You cannot say, okay, we will digitize the production and we will forget all the rest. It will not go like this. You will have to digitize the complete company by the systemic approach. You need to be on top of the different processes you have with a company. And as Sébastien said, you need to work a lot with all the process engineers, all the people who know how it works, and then you can try to digitize these processes. Digital continuity, this is also very, very, very important. We see a lot of our customers that, for instance, they do the design of the equipment, and then the design is not directly transferred to the workshop, which is problematic because you are using export files, you break the chain, which is not the case if you are using a complete collaborative platform where the information is going from one department to another, lean, I would say. And then also, we have a lot of discussions with our customers because ERP, we speak about ERP for 20 years now. but the MES, Manufacturing Execution System, is coming more and more, and there are lots of discussions concerning the connection between the ERP and the MES. You need these two systems to speak together, and there is a lot of discussion around this subject. This slide is important because it's a summary of Industry 4.0 or smart industry or industry of the future, depending on the country we speak about. But here in Luxembourg, we speak about more smart industry, I think. So you have there where you have the line equipment. So you have all the equipment working together, and you have a lot of data connected to these equipments. So as Sebastian mentioned, what is very, very important is to connect all the data, to catch all the data. So this is why at Cpi we speak about data acquisition or data collection, because we often forget this step for the digitalization of the production, but it's very, very important. And we speak about CMS, condition monitoring services. This means that because in your workshop you will have machines which are ready to connect. So this is easy. You do the connection via the PLC or via the controller, but you have all the machines. They are not ready to connect at all. And then you need to speak about IoTs, and you need to speak about transfer protocols and blah, 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 all that stuff. So it's very important. It's quite complicated, but without the data, you will do nothing. Without data, you cannot digitalize your production. So this I insist on this. It's very, very important. And when you have your data, you can do dashboardings, but then it's the visualization of the data. For instance, you need to track the temperature of a tool, or you need to track your OEEs. All this is dashboardings. Then with the data, you can go one step further and use these data for the ERP, for the MES, for the QMS. So all the enterprise management system, but completely digitized. And then you have the one step further is the analysis. You have all the data, but what are you doing? What are you doing with the data? So you need to put to do the analysis of the data and to put more intelligence. And this is why we spoke with Paul Wirth some weeks ago about this, and then we have adopted, I would say, because we are now VAR for this solution of data experts that Sebastian mentioned before. So you have the different steps. You have the equipment, which is a reality, and then you have the digital part of your enterprise with the data collection, with the MES, QMS, and on all of this digitized part of the company, and then you analyze your data. And then we are also you can also work with putting the digital again back in the reality. This is what we name mixed reality through some HoloLens glasses, for instance. And then we are using this at Cpi for complex maintenance processes, for instance, or for training. So it's really important. We speak about reality, we digitize, and then you can go back in the reality with mixed reality. So for us at Cpi, the slide you are in front of you is very, very, very important, because it's a kind of summary, I would say, of what Industry 4.0 is. Okay, then the question is, how do we go from the classic industry to the smart industry? So for me, the most important word is methodology. You need to define, to take the decision to establish kind of planning. Then you need to prepare the organization. Something very, very important is to have the employees on board. As we said, it's not magic at all. You need to understand your processes, and the people of your company, they need to understand why we go for digitalization, why we are doing this. They can say, okay, we have been working for 30 years like we are working right now. It's okay, we are there. But so you need really to make them understand that we say what makes sense. Why do we need to digitize our production? The answer is it's mandatory. We have to, because the story is like this, and if I don't do it, my competitors will do it, and then we lose the market, I would say. And when the implementation is done, you need also to check with KPIs. We are discussing a lot of way of, I would say, managing the digitalization of the production by key indicators. So the key factors are quick start of the transformation, I would say, because it's mandatory and we need to do it quickly. It needs to be human-centric, like we say, because it's not magic. It's not a soft that you will install somewhere on a virtual machine and then it's going on. No, it's not like this. Of course, you need to install all this, but the key elements are the employees of the company, and you need also to give sense to the change. You cannot impose this from the CEO. The CEO will say, okay, we need to change, and then all the organization will follow. It's not like this, according to our experience. Of course, the CEO will have to take the decision, but then all the people in the organization need to understand why we are doing this. And then all these numbers are coming from our customers. Okay, we can discuss all day long about is it 70% or 75 or 65. I would say it's not the point, but it's with digitizing the production. You have meetings, for instance, if I take this one, you have meetings more productive. We have a customer who was saying to us, okay, every Monday morning we are doing the planning of the workshop. So we were going machine per machine, asking what is going on, what is the work order, what is the shop order on the machine. Then we are back in the office, trying to gather all the data, doing the planning, but there was no connection, because when the planning or the status was done, it was already wrong because it was not directly connected in real time to the production. It's an example. And with real time, in fact, you have the correct data at the correct time to take the good decisions. It is very, very important. And if I had only 2 seconds or 3 seconds to conclude this intervention, I would say the most important is, with digitizing your production, you will get the correct data at the correct time to take the good decisions. It's very, very, very important. Okay, you will find here the contact details of the company on my contact details. Thank you.
Thank you very much, Pascal. I think that's very interesting to hear. I would say what you have shared from the whole work you have done with your customers and the whole experience there. I mean, I think if I see again a similarity between two presentations, the stages and the steps, the blocks, starting from the data, collecting them, and then after that, the whole maturity goes with that. But I think one key factor I could also hear from two presentations is definitely that in any digitization program, the human factor is key. You will not do without the human, being the people from the process, being the new famous data scientist that Bastien mentioned earlier on. The human side, I mean, the human-centric approach will actually discover and discuss in a specific webinar in September. But I think that's a very key and important element. And I think, I mean, a lot of what you have shared here also apply, I think, as you have said, that you don't need to be a large-scale industry, as you said, Pascal. I think you, as a mid-size, 50 staff industry, I mean, you have customers that have done that and came with those type of results also. It's about what you said, an element of methodology to start, right? That's a key point as a starting point from a small industry. If you could share from a very small industry, what would be the typical starting point? Maintenance, connectivity of the machines, what would that be?
We are currently doing a project with let's say a small company located in France. And their main issue, for instance, is to know the status of the production. So that they are in the workshop some machines which are ready to connect, on some other machines which are not. So we are working with easily with the ready to connect machines and with IoTs, and it's really their start point. They know that they will have to go further to use a collaborative platform, but they said to us, okay, our first step is we want to know the status of our machines in real time. So this is the first step, and we are working with them on doing this. And we are also thinking about the next phases of the project. But it's true that for small or medium-sized companies, to phase the project is very important because you cannot change everything at the same time. So they said to us, the most important problem that we have is we don't know the efficiency of our equipment. So we need to know this. Said, okay, fine. So we start with this. We know that there are a lot of things we can do, but we would do this step by step. From small and mid-sized companies, I would say the step-by-step approach, according to us, it's the good one.
Thank you very much. Then I would like to go back to the audience, and then we're going to take the questions. If you can go into the next call, and if the team could, thank you. So on the next question I have for the audience, and we saw the relative age of the production tool, but then the data is at the core. I think it was mentioned about connectivity in the ERP and the CMS. The question we have for you, the audience, is the following. How open and connected is your production line or production tool? Is it or completely closed? I can extract data from production. Or B, I can extract some data, but it's very specific proprietary interfaces. So meaning reading that not simple. Or the third one, I can extract all the data I want from my production line production tools via an open interface. I think it's interesting to see and correlate that. I will leave the audience basically to submit their vote there, and then we're going to see the result. But while we are doing that, I will take a first question. We know we have a lot of questions, Sébastien, that are actually linked to. I'll just stop sharing my presentation so we can see each other. A lot of questions about the whole artificial intelligence and machine learning. I think if we go to the first question that came to you, Sébastien, I mean, do you see whether machine learning put on top of your own rule-based engine results is increasing innovation pace in your segment of blast furnace?
Well, in innovation pace, we don't do that to really innovate, in the sense that if you implement machine learning, it's just to optimize the production and minimize the production cost, and you know, the case of the customer is reducing the CO2 which is produced, which is one case. You don't do that for the sake of innovation. I don't believe in that. The thing is, if you are, let's say, if you are a cook and you are doing a cake, you don't care about how the microwave is working. You know the recipe, you know what you want to achieve, and then you mix the recipe and you put it in the microwave. Machine learning is the same. You don't have to know how machine learning works. So if you have data scientists which are coming with a new microwave, you give them 50% of your recipe, and you keep the 50% hidden from them, and then you proof test once you have the microwave if it works or not. The thing is, the most important is to acquire the data, but the data alone is not enough. So you have really to go back to knowledge management. Knowledge management was something really at the top of the hype in 20 years ago. We tend to forget how to exchange knowledge, and Pascal mentioned the silo. The silo between the department still exists today. So you just make a purchase order, or you send to a workshop. Imagine today the small workshop are still receiving PDF, where in fact the model were done in 3D. So it's a bottleneck for them, because they have to reproduce from a PDF, a 2D to 3D, where they could have directly this kind of 3D model. And in the end of the day, when you connect the machine, as Pascal said, if you connect all the milling machine in a workshop, and you have all the data about the processing, and you link it to the planning, a part in the quality inspection is not okay. So you can go back and identify which machine was wrong and why it was not be maintained, why the quality of this part, where it's coming from. And identifying the bottleneck in every production line should be the first aim. Not really say we're gonna make innovation. No, we're gonna optimize the production and minimize the cost of our companies. And a lot of people cannot identify the bottleneck. That's why they have to sit together with the maintenance and analyze with the quality department and all what bottleneck is present in my production line. That's the first step.
Thank you. But I mean, if we go back to the results of the polls, which are interesting, because at the base it's about sharing data, and then of course you can go on the multiple blocks, and then you have this machine learning. We have a lot of questions about that. That's very specific, and hopefully we're going to take them at the end or separately. But if we look at the poll, it's very interesting. We have 25%, the whole tool is closed, so I can't even extract the data. And for 63%, it's true. I won't say it's through proprietary interfaces, meaning it's not exactly simple. So only for 11%, so for 10%, it's kind of simple and easy to do, which we can also correlate to the fact that most of the investment have been done with, and production tools are 10 years old, which is normal. You go into cycle that would be 15, 20, 20, 35 years. So how to approach this famous first pile block, which is about data gathering in an environment that seems to be pretty close. Maybe Pascal, you want to start on that one?
Yeah, I wanted to try to answer this question. When we started thinking of all this, we have quickly understood that okay, the data acquisition or the data collection is something important, because without the data you do nothing. But it's difficult to get it, and it's because in the workshop you have different trades of machines, you have different ways of communication protocols, and this is why we have developed an R&D project around this subject. And I would say the main thing is to try to understand how you can collect data from different trademarks of machines, and we are currently doing this. And I can tell you that when you have understood how to do it, you can do it. But you have to have a lot of discussions with the CNC machines manufacturers, the controller manufacturers, the PLCs manufacturers. They have all different protocols, but you can. It's possible. We are doing it in a workshop currently. You can gather all this information and put them on a Kpi server, for instance. Based on this, it's a kind of hub. You gather all the data, and with this data, then you can send them to MES, for instance, or to data experts, for instance. So you can use the data. So this is why this project was very, very interesting for us to understand and to try to jump, I would say, the technical barriers that were there. There are some, but we know how to do it now. But it's important because, as we said, you do not install a soft, you need data, and then say, oh wow, but where are the data?
So clearly, I mean, if we understand clearly, there is no discussion, there is no need to discuss about machine learning as long as you haven't basically been able to do the first blocks, which are about gathering the data, validating, and doing that steps. But each of these blocks, to come back to your presentation, Sebastian, brings an added value, and to yours, Pascal, brings an added value to the company, to the manufacturing process. And then when we go into the latest blocks, they bring additional revenue, of course, value. And we have a question about the democratization of those tools that are from machine learning. There we get into really the high maturity side. I mean, do you see a trend about those tools to start to be and democratization from price point of view, but also accessible for not exactly PhD degrees type of profile? Nothing against PhD degrees, though. But
no, that's they are good. We need them to define the complex machine learning algorithm as well. But the price of I'm often surprised to see that people are coming with large budget for that. I must say we have an R&D project a budget that is huge inside product for sure. But if you take big companies I know based in Luxembourg, they made predictive maintenance for 50,000 euro per year, and for that they are able to monitor 40 machines which are key in their production line. And speaking about data acquisition, of course it was locked. The data of all the engine were locked. And this solution, in fact, is coming from a startup. You are connecting that to every engine of your manufacturing line, and then you get the data. If they were not able to read them, you install a new sensor. And it costs, let's say 1,500 per machine, which is maybe a lot for some people, but for this company, it was peanuts. And another example is a data acquisition box using Sigfox, for instance, and a sensor. You want to have a temperature or pressure sensor. You can get that on the market for 200 euro. So it's not expensive. What you need to get is what are, in fact, the data you need. I take an example of, we have a gas company in Mexico. And they call one of my startups here in Luxembourg. There are 3 in the startup, and they are just making sensors and acquisition box using Sigfox. The first step was for them to see, because in Mexico you have the gas tank which are in the countries, and you had the truck going there to fill in the tank, which was not empty or almost empty. They didn't know what was the level of this tank. So they just placed, quickly they made an MVP, and the MVP cost 500 euro. They made an MVP on one tank, and then they get the signal and then the simple dashboard. And then they just extend that to the different tank. That was the first step. On the dashboard, they could see what was to be filled, where they should send the truck. That's the first step. The second one will be, okay, let's apply artificial intelligence now, because I have my truck, how to optimize the road my truck will take in the morning to fill in the different, and that's the step after. The first step is to validate the data acquisition, having a dashboard, and then you scale up. And for that, you don't need to spend thousands of euro in the beginning. You have to start small. The milling machine are quite close, that's clear. But there are interface for that, and Pascal is certainly really knowledgeable on that. It's really important to connect the different machine, and there is always a way. If you don't have a way on the machine, on the milling machine, you can just analyze the electrical consumption, for instance. And if it's and if the milling machine is not optimized, let's say the path of the tool is not optimized, the consumption will go away because it used too much power. Then you can identify, oh, the path is not optimum compared to what the machine can do. And you can understand that only if you go the worker which is operating the machine and saying, oh, at that stage, I had a ultra huge power consumption. What happened there? And you must say, yeah, I had the wrong path. It was too deep. The tool was too deep, so the machine was just ramping up in power. And that's the exchange of this knowledge that can help. But the data acquisition, it can be cheap.
But again, coming also to Pascal's point, I mean, if the machine itself is closed, you can add sensors, cameras, or whatever on top of your machine to get actually data, which is another aspect to do. I mean, thank you, gentlemen. I mean, time is flying, unfortunately, in such important and core topic. So I want to thank you all for joining this webinar. I mean, we'll have the replay. It will be posted on our new platform, which are of the Digital Innovation Hub. So I invite you also to go there. Gradually, it is going to be enriched. It has been launched just last week. We're going to find more and more, be it from a supplier side, from a customer side. We are, with the next session, will be coming back into the fact that the human side in digitization is key. So our next session will take place on the 23rd of September about the digitizing the employee experience and how the role of the human into digitization actually is key. So I want to thank you again, Pascal and Sébastien, for sharing your knowledge here, your experience. I want to thank the audience for having stayed a bit longer than foreseen and for your question. And you have the contact. So if there is any specific follow-up to be done, feel free to do so. Thank you and enjoy lunch.
Thank you.
Bye-bye.
Bye-bye.